I'm Brady Gaster. I am a PM on the .NET team and the Orleans team, which is kind of the same team now, thank goodness. And you want to introduce yourself?
Yep, I'm Ruben Bond. I'm a software engineer on the Orleans team.
Cool. And today what we're going to talk about is, I've heard a lot of people talking about like the various performance things that we've done in .NET 7, and I've heard a lot of themes about cloud native this week. To me, I kind of have an answer as to what, one of the things that's important in cloud native. And I'm going to go ahead and pull up the Orleans slide here and introduce the topic of Halo. So to me, Halo demonstrates one of the core tenets to me of what it means to be cloud native. And that is that you support horizontal or severely dynamic scaling at any given point. And that you support being able to be deployed in multiple regions. And you're always on, et cetera, et cetera. Halo currently has a lot of stuff built on top of Orleans, essentially most of the back end. So if you can imagine, if you're playing with Master Chief, and wherever you are in the game, the presence is all implemented with Orleans. We've also implemented statistics, like user statistics with Orleans. What are some of the other things that we've done?
I think anti-cheat.
Anti-cheat as well.
Matchmaking.
Yep. Okay. Matchmaking. That's going to be key because one of the canonical ways that you can use Orleans is definitely in identity and presence. But it wasn't just Halo that built their service on top of Orleans that could scale to millions of users and millions of Microsoft customers. It was all these other organizations too. So we're going to talk about a few of those, and Ruben's pretty dug in on some of the technical details of how some of them were built out. First one I'll talk about is Azure IoT Digital Twins. If you think about a service like Digital Twins, for each device that you've got in the field, you've got some sort of a digital twin representing that device in a back-end system somewhere. For Orleans, that's a one-to-one. So each one of those devices is represented by an individual object in cyberspace, if you will, in the cloud, if you will. Gears, same thing. Gears of War, just like Halo, they built a lot of the different back-end, being able to track presence of individual users, being able to track stats and matchmaking, all built on top of that. Fraud protection, we just talked to them. What kind of stuff are we doing with fraud protection?
That's right. So they're using Orleans to monitor, say, for example, purchasing fraud or login fraud and all different kinds of fraud, and using grains to track the individual objects in that domain. And then calculate the fraud risk for a given thing and prevent fraud.
That's incredible. And then Microsoft Mesh is a team that we speak with like once a week. I think we have
every 2 weeks.
Yeah, every 2 weeks we have a sync up with them. All the different things in the Microsoft Metaverse product also built on top of Orleans. And I see down at the bottom Azure Orbital. Maybe one day Orleans will drive spaceships. Who knows? But if you think about all these different services, these are services that power millions of devices, millions of customers every day, and they're all built on top of Orleans. If these services can scale out to millions of users on Orleans, pretty sure your systems can as well.
That's right. Yeah, using Orleans in some capacity in each one of these.
Different, like AAD's not using it for a lot of stuff, but
traffic management, I think, is the AAD use case. But either way, some of them are built completely on Orleans, for a very fundamental use case, and others are built using, say, some of the more services to the side.
Cool,
right?
Cool. And what we'll talk about later on in the talk today is some of the features of Orleans and some of the benefits that Orleans gives customers. And what you'll see is that you don't have to use the persistence and the reminders and this and everything. You can kind of pick and choose what you want to use from the Orleans framework. But moving right along, one of the things I like to kind of talk about with ASP.NET developers is how Orleans adds distributed processing to ASP.NET Core and how it adds the capability for you to do things like distributed state. If you don't really do a lot of web farm out, where you kind of look like this, you might not run into these problems. When you're building a pretty small ASP.NET Core app, it'll perform on one host, one server, one virtual machine or app service. It runs just fine. But once you start to get into this situation where you've got your ASP.NET Core app scaled on a web farm or in multiple servers or you're multiple honing it, especially in a situation where you don't have sticky sessions enabled, just as for instance, you might not know what server your request is going to get back to. So the state on that server might not be the same as the state on some other server. So at that point in time, you might have an issue. So what Orleans does is it adds a layer beneath all the existing stuff in the ASP.NET, or not, I keep saying ASP.NET because I'm an ASP.NET person, but it adds a layer beneath .NET, if you will, where you can actually persist these objects called Orleans grains, which is sort of the primitive object in Orleans. And the idea behind these grains is that they obfuscate the concept of the host. They obfuscate the concept of the server. At any given point, any of these .NET, services could make a call to a grain, that could make a call to another grain on another server, or that could make a call to another server and another component somewhere. So I might have a worker service that calls a grain, and then that grain makes a call to a SignalR hub somewhere through what's called a Orleans observer, which we'll talk about a little bit later on. But this just kind of shows you like how Orleans runs underneath all of this stuff. So if you think about things like distributed cache or distributed session state, it's going to be fantastic for those scenarios where you really need to kind of persist data so that all of your hosts can share. So that's kind of your primitive way to use Orleans. Did I forget anything in that? Is that kind of all right?
No, I think that's about right. And so you can imagine, for example, if you're building something like a shopping cart, you might have a shopping cart grain for any given user. Now, between requests, when the user's adding things to their cart, they might not land on the same server, right? Because they're going through a load balancer, it's round robining them, for example, and so it's landing on a different host. But in your application, let's say it's a minimal APIs application, you can say, I want to message that person's shopping cart, and I want to add this item to their cart. You don't need to know which server that's loaded on. Orleans will hide that from you. You just say, I want to message that object, and Orleans will do the routing for you. So it'll decide which one of these servers that shopping cart is loaded into memory on, and then route the message to it and route the response back to you without you having to worry about it.
That's great. So when you think about things like service discovery, which is a typical concept in cloud native programming, you not only have to find your endpoint, you have to find your server. With Orleans, it's just you call the object.
Exactly. Yeah. You don't have to worry about service discovery here.
Right, exactly. It's just there. And we'll talk a little bit about how you identify a grain or how you identify an Orleans stream a little bit later on when we get into Benjamin's section of the presentation. But let's go ahead and move right on real quick. Orleans at a glance, if you've never really done anything with it, here's just kind of a smattering of the different features that you can use Orleans for. The number one thing, persistence. You can actually use Azure Storage, Cosmos DB. We have a wide array of different database backends that you can actually store your data into. Whenever you're doing that storage, you can actually use ACID transactions across the board, and everything's going to work. Like Ruben mentioned a minute ago, in the case of a shopping cart, you don't want to ship somebody their product until you've done the process of billing them and making sure everything's going to work out. So you can implement all of that in Orleans. It's pretty transparent. You don't have to worry about the lower level transactional stuff. Orleans just kind of takes care of it for you. Observers, I mentioned a little while ago. Observers are great for when you want to send a message to a client from, say, a grain on the back end. An observer can essentially observe every single thing that happens inside of a grain. A grain can call an observer. The observer can bubble a message up to a SignalR hub, and then you can bubble that message all the way back to the client. One of the demos that you're going to see Ruben do later on is actually going to be a great canonical use case for observers and SignalR, two of my favorite tech. Yep. So it's kind of good. And then call filters. You'll see at the very end here, we've got this thing called call filters. One of the things that we'll see Ruben do a little bit later on is we'll see him use what's called OpenTelemetry with our Orleans stuff. And essentially what that means is he can actually create a call filter that intercepts all calls to an individual grain and then send that data somewhere. So we've got one open source package called the Orleans dashboard written by our good friend Richard. And in that product, he actually does call filters to observe how grains are operating so that he can essentially draw a chart so you can actually see kind of an admin view of your cluster, your Orleans cluster, and kind of see how everything's working. Deployment freedom, anywhere .NET Core can run, Orleans can run, as long as you have that database backing it up. You can run it in Kubernetes, GCP, AWS, of course you can run it in Azure. Some of the services we talked about earlier, like Microsoft Mesh, they actually run their Orleans backend on top of Azure App Service. So you could actually do that. And you'll see some docs later on when we talk about stuff. Azure Container Apps is another great place for you.
Or your laptop.
Or your laptop, yeah it's good
just
too.
Just hit F5.
Yeah, you can just hit F5. Pretty much anywhere you can run .NET Core. So those are the basic underpinning features of Orleans. But what I want to talk to you today is Orleans 7. So we did Orleans 3X, and I actually went on vacation, and I went and did a keynote somewhere, and I came back, and Ruben was like, "Oh, it's Orleans 7 now." So we did that to basically map to the .NET version branding, and that should send you a message. The Orleans team and the .NET team are one now. And essentially, you can think about Orleans as a component of .NET moving forward. It's going to get closer and closer to being in the box. These are some things that we've done for Orleans 7. There's going to be a lot of improvements in Orleans 7 that Ruben and the team have wanted to make for 6 or 7 years now, that we finally just ripped the Band-Aid off and went ahead and made some tough changes. Some of the benefits of those is going to be version tolerance. So in previous versions of Orleans, if I had, say, a shopping cart class that kind of represented the state of my object, or the state of my entity at that point in time, I would have a finite number of properties, and once I actually ship my product, I'm not going to be able to add any more properties to that. With Orleans 7, you can actually extend those objects and get them further, and actually you can do version tolerance, and I can have version 1 of my grain versus version 2 of my grain. Can we do that in the same cluster?
Oh yeah. So if you want to do a rolling deployment, you can add a property, and even on interfaces. So grain interfaces, you can add new methods, or you can change methods. And you can actually put a little annotation on top of the grain interface and say, this is version 2. Cool. And Orleans is smart enough to know that if you're messaging a version 2 interface, it needs to route your call to a silo that has that version 2 interface running.
Cool.
So if your grain is on a version 1 host, and you're doing a rolling upgrade, it'll migrate that grain over for you automatically to the version 2 host.
That's good. That's good. So you don't even have to worry about like API versioning at that point. It's just,
cool. Version tolerance for real services that are actually operating is extremely important. And this is something that traditionally has been a major pain point in Orleans.
Yeah. Another major pain point, well, it's not that big of a pain point. It's an opportunity, has been the ability for us to have a more simple, he says it's a pain point. I probably agree with that.
I'm an engineer.
Yeah, so. He's an engineer. Is the ability for us to provide you with a more simplified way for you to identify grains and streams. In the past, you'll see Benjamin do a demo here in a minute around grain identification. In the past, you could identify it in a lot of different ways, and that led to confusion. Now it's all strings.
Yeah, so this was especially a kind of problem when you want to refactor your classes, or if you're using generic grains. And the way that was represented previously was not really amenable to, well, it had a few corner cases in the generics case, and it wasn't really amenable to version tolerance again. Okay. And so just continuing with that theme of operational excellence, this is one of those important things that we want to have.
Cool, that's good. And that's why we had to make some of those tough choices. Moving right along, one of the other ones I'm going to get into a small little demo. I'm not going to really do anything exciting during this one. That's Ruben's job here, is to talk about some of the enhanced developer experiences that we've kind of done to kind of make things easier with Orleans. My favorite one of these is that in the past, when you wanted to get started with Orleans, you'd have quite a few NuGet dependencies that you'd have to add in. We've done a good job of simplifying a lot of that. So let me kind of show you what that looks like in the code real quickly. So over here, I've got Visual Studio open, and you'll see that I've got just a simple pings project. And the idea is, if you look in my abstractions, I've got a ping grain and I've got a ping message. And essentially, I'm just going to be sending, a ping grain and a message. Let me zoom in just a little bit so you can kind of see everything. So this is really just my abstractions project, which is where I would have created all of my grain interfaces. So what I'll do here is I'll open this up, and you'll see that I've got to know, and I always forgot this, and I've talked to other people who did too, you've always got to reference this Microsoft Orleans code generator.msbuild because we do a lot of code gen stuff. And then I'd also have to reference the Microsoft.orleans.core abstractions. Now that was just if I wanted to start building grain interfaces, just to use all the basic Orleans stuff. We've made that a lot easier for you. Today in Orleans 7, all you need to do is reference Microsoft.orleans.sdk. And that brings down everything that you need, the code generators and the whole nine. Now, if you wanted to start working on what we call as an Orleans silo, an Orleans host, there were even more. I'd have to bring in hosting. I'd have to bring in the code generator again. It seems like I would have gotten that with abstractions, but I always had to do it separately. I have to pull in abstractions, and then there's the server, which is the one I would expect to have to pull in. And then in this case, I'm using the Orleans dashboard, so I had to pull that one in. Well, with 7.0, it's one package, Microsoft.orleans.server. And you're off and running. So that's good. And then the same thing is true for client. It would be Microsoft.orleans.client. So at that point, you really just have that one package that you have to bring in. I think we counted it as 3 at this point.
Yep.
If you're building a client, you're going to want to have Microsoft.orleans.client. If you're building a silo, you're going to want to have Microsoft.orleans.servers. Server.
Yeah, server.
That's exactly, I always want to say silo there. And then everything else, you want Microsoft.orleans.sdk, and that brings everything in. One of the things that we've alluded to in some of the talk so far is that there's a couple of things that we've done that are, for all intents and purposes, going to be a little bit of a breaking experience for those of you that have been doing 3x and now you're going to move into 7. The one that bit me the other day, I want to go ahead and show it to you right now. So this is essentially one of my model classes that I would use inside of my grains. My ping grain uses my ping message. You'll see here that everything in 3x had to be marked as serializable. So I had to mark my info objects as serializable, and then I've just got my properties and I'm off and running. We've made some significant improvements in serialization that this man can tell you a little bit more about than I can at this moment. But one of the bad parts about that for you as a developer is if you're moving from 3x to 7, you're going to have to do a little bit of a change here. Instead of using the normal serializable attribute, you're going to want to do generate serializer. And then on your properties, you're going to want to decorate it with these attributes. But we've made that part easy for you as well. And if you've got an info object that you've got and you put that generate serializer, we've actually given you a Roslyn extension that will, or Roslyn code fix that will generate the serialization attributes for you from top to bottom. So that makes that part of the development experience a little bit easier. So you essentially you would go into your 3x code, change serializable to generate serializer, and then you use the Roslyn code fix to put all the attributes in for you. So we wanted to make that at least as easy as we could for you. But like, what do they get for that little bit of pain?
Well, you get a lot of performance. So performance in Orleans 7 is much faster, and part of that is this new version tolerance serializer. But it's important that when you're doing version tolerance, that you're very explicit about what your data types are, so that you can evolve them knowing full well that you're changing a type that's being either persisted or at least sent across the wire between different machines. Right, and so being explicit there is good. You know, we could remove all of that stuff and make it just like it was before, where you didn't have to say anything and try to infer which types are going to be sent across the wire and generate code for those. But in doing so, it would be more of a minefield if you were to go and change things. Right. You might not know which things are having serializers generated and which ones aren't. Right. So being explicit in this case is good.
That's good. That's good. One of the things that Ruben alluded to is that actually adds to the already fast performance of Orleans. We already had great performance, but we've got some pretty dramatic performance improvements on the next slide. And as Ruben's going to show you a little bit later on, some great open telemetry support. But I want to go ahead and give him and Benjamin time for their demos. So this is our dramatic performance slide. You can see here that in these, this is a set of 3 tests that we run, which is essentially silo to silo. So it's server to server over a TCP connection. Client to silo, which is one client, one server over a TCP connection, and then one client and 2 silos. You can see here that the performance is out of control. And with the first machine here on the far left is a small Azure VM, and then we've got my laptop, and then Ruben's laptop, and then Ruben's desktop. And you can see that the performance goes up as we go down the pipe. In some cases, we're getting as high as 60 or 70% performance, all the way up to 100% performance in some of these tests. But here's the exciting part. There's another way that you can run Orleans. Let's say you've got a minimal API, or you've got a view or a SignalR hub, and you want to dial into some grains that are in that back end of your system. We call that hosted client, and that's essentially when you've got a piece of .NET that talks to Orleans. Look at the performance improvements that we've got there. In some cases, we've got 400% improvement in that case, and we think that's kind of where you're going to want to use Orleans because it's an ASP.NET world. We're going to want to have APIs that talk to Orleans backend. You can see here that we're the performance is pretty much out of control at this point.
That's right. Yeah. So you can optimize the placement of your grains. It's very configurable. And if you are calling in application, like for example, if you're calling a stateless worker or a local grain, then you get to make use of that optimization where it doesn't need serialization. Of course, it doesn't need networking. And so you get much better performance there.
That's good stuff.
Versus TCP.
Cool. And now we're going to turn it over to our buddy Ben. It's the middle of the night, so he's recorded a video for us. And we're going to go ahead and play a demo video from his office, which is apparently in a vineyard in France. So we'll go ahead and let that play real quick. Over to you, Ben.
Hi, I'm Ben. I'm a software engineer in the Orleans team. I've been working on this project for more than 6 years now. And today, I will speak about some new exciting feature of Orleans 7. The first big change is about grain identities. Previously, grains were identified with a compound type to support keys of either GUID, long, string, or a combination of GUID and string or long and string. This involves some complexity when dealing with grain keys, since they supported various types. Moreover, the type was represented with a numeric type code with some bytes reserved to deal with generic type. Grain identities now take the form type/key, where both type and key are strings. This change makes it simpler, more flexible, and more human readable. It is also solving some issues with generics. Let's see in this example, in 3x, you see you have to deal with a key type explicitly. You don't call the same method to get the grain key. You either have to call the method for getting a string, or a long, or a grid, or any other method to get a compound type. Now, all keys are represented with a grain ID. And this grain ID has a string representation that is very human readable. In this example, we will display grain consumer / some key activated, where consumer is a type of the grain, the class name of the grain, and some key is a string key of the grain. Similarly, we change the stream ID. Before, streams were identified with a stream namespace and a GUID key. Now, this key is a string, which will improve usability a lot. As a result, implicit subscriptions are no longer limited to GUID-based grain. In this example, we have a grain with a string key that is implicitly subscribed to a string.
Great. Thank you, Ben, all the way from France. Can we switch over to my slides?
Yeah.
Ben. So I just want to show you quickly some of the observability enhancements that we've made in Orleans 7. And I'll show you a demo of us using OpenTelemetry to look at traces as well as metrics. So first, I just want to quickly overview observability for cloud-native apps in general. Now, if you've looked into this topic, you may have heard that there are 3 pillars. There's logging, there's distributed tracing, and there's metrics. Now, in the past, we've supported logging via the Microsoft extensions abstractions logging, or logging abstractions rather. But in Orleans 7, we've also introduced distributed tracing and metrics, thanks to the new improvements in .NET 7 itself. And so for distributed tracing, we're using the standard inbuilt activity source metrics, the activity source class, and for metrics, we're using .NET metrics. What I want to show you is an example using the GPS tracker app. So this is one of the samples that we've got up in the repository that I'll show you later. How does this all fit together? There are a few moving parts here. So I'm going to be running this sample on my laptop. And so we're going to have this GPS tracker service on the left here. And there are 2 parts that we need to know about. First of all, we're going to be scraping metrics from the application itself. And so I'm going to have Prometheus set up inside of a container that knows how to scrape metrics out of our Prometheus endpoint in our app. And then Grafana is going to be using Prometheus as a data source. On the other hand, with distributed tracing, those are actually pushed out via OpenTelemetry using the Zipkin protocol, either to Zipkin or Jaeger. And in this case, we're going to use Jaeger. Okay, so let's get right into it. I've already got the application, the GPS tracker application running on my laptop here. Let's just have a look at it working. So you can see these little drones flying around in real time around this little area in San Francisco. The first thing I want to show you really quickly is that you can monitor your application without doing any code changes at all. And so using the .NET counters tool, you can quickly, I'm just going to zoom out so you can see what comes up here. You can quickly monitor it using the Microsoft.Orleans counters. And so as soon as Orleans starts spinning out counters, you can see that we're making about 2,500 calls per second, and they're all taking less than 1 millisecond time. All right, and so if you do want to do things like, for example, look at metrics inside of Grafana, though, you do have to set that up. And so I mentioned how we had Grafana configured so that it would be scraping from Prometheus, which is scraping from our application. And they're both running in a Docker container. And we've got a dashboard set up that lets you observe some of the things inside of Orleans. So these are those same counters, but now exposed via Prometheus. And finally, I want to show you what it looks like to use Jaeger. And so if we have a look here, we can see that our application is pushing slice spans up to Jaeger, and we can hit find traces. If Jaeger is alive, then we should get some traces back. But after running it for a while, it does tend to run out of memory and crash, which might have been what happened here. But that's OK, because I've got one I prepared earlier. And here is an example showing us which grain is sending a message, which grain is receiving a message, or the other way around. The methods that are getting called, and the interface that's getting called, and this will flow all the way through to HTTP or whatever else is supporting distributed tracing. Now, the code to implement this is very simple. There's not much that you need to change inside your application. Like I said, to use .NET Counters, that's no changes at all. To use Prometheus, you do need to add open telemetry packages, configure Prometheus. This is just like what David Fowler showed you this morning. And Azure Monitor is similarly a one-line change. To use distributed tracing in Orleans, you also need to add, aside from those things and determining that we want to trace the runtime as well as the application, you need to tell Orleans to enable distributed tracing. So it's really quite simple. You can see this package online, this sample online. The final thing I wanted to show you was we have documentation up on Microsoft Learn, so learn.microsoft.com/.net/Orleans. We have a repository of samples here up at aka.ms/Orleans/samples. And finally, you can connect with us on Discord, Twitter, or GitHub. Thanks, folks.